Hello students. It's been a very long. Hope you all are doing good. So, we are left with a major topic, which is equation of continuity. So, before dealing it, I just want to tell you, I just want to remind you the few things which are nothing but what is generation, what is recombination, and what is mean lifetime. Generation, recombination, and mean lifetime. As you all know, generation is nothing but by taking some energy, the electron in the valence band goes to the excited state, which is the conduction band, which goes to the conduction band, leaving a hole here. So this is nothing but the generation. In generation, always a single charge is being divided is actually giving rise to two charges. Single charge kasta, it is becoming as two charges. One charge is hole and the other charge is electron. So here we are talking about recombination. Recombination ante entama? As we all know, recombination is nothing but the electron in the excited state comes back to the valence band, which is its original state, comes comes back to the original state, and then it recombines with the hole, comes to its original state, leaving the energy outside. So this is recombination. Now what is mean lifetime? It is nothing but the average time taken by the charge, taken by the minority charge, or just charge in this case. Okay. So mean lifetime is nothing but the average time taken by the charge after the generation and till the recombination. వెళ్ళి మళ్ళీ రికంబైన్ అయ్యే వరకు ఉన్న టైంని వీ కాల్ ఇట్ యాజ్ మీన్ లైఫ్ టైం. These are the three things which I told you twice already, and this is the third time I'm going to tell you. I just want to make it a revision because this topic actually depends on this three things. So బాగా గుర్తుపెట్టుకోవాల్సిన విషయాలు ఏంటి? The one is in generation, the electron will be divided, the single charge is then divided to the two charges, one the electron and the other is the hole. So two charges అనేవి generation లోని డెవలప్ అయ్యాయి, and at the same time రెండుగా ఉన్న charges అనేవి మళ్ళీ ఒకటిగా అయిపోయేదాన్ని రీకాంబినేషన్ అని అంటారు. And what is mean lifetime is what I told you. I don't want to repeat it once again. So in this, we are going to see in this equation, it is nothing but a differential equation. It is nothing but a differential equation which says that the carrier concentration varies with respect to time as well as distance. సో టైం ఇంకా డిస్టెన్స్ యొక్క వేరియేషన్స్ తోటి మన క్యారియర్ కాన్సన్ట్రేషన్ కూడా మారుతుంది. అది ఒక ఈక్వేషన్ రూపంలోని we have put it in an equation, and that differential equation is said to be an equation of continuity. So for that we have to do something to prove this statement kada. For that we are going to prove the statement by just taking a very small semiconductor in the form of cube. Let us consider a semiconductor in the form of cube. Okay, now semiconductor which is in the form of cube, small infinitesimal small semiconductor. So this is having the length dx and the area which it is occupying is a. ఎలా అని అనుకుంటే లెట్ us కన్సిడర్ దీని మీద ఒక క్యూబ్ పెట్టాను. ఈ క్యూబ్ పెడితే దీని యొక్క ఏరియా which it is occupying is a. At the same time the length is dx. So when a is multiplied with the dx, what will what will it represent? It will represent the volume. Avuna kada? So it will represent the volume. So V is nothing but A into dx. Now, to prove this equation, let us consider only holes present. Carrier concentrations అనేవి we have seen in terms of holes as well as in terms of electrons. Electrons is represented, carrier concentration of electron is represented with which letter? P or N? It's a question. Okay, since it's a virtual mode, I can't talk to you. So N is representing the electron carrier concentration and P is representing the whole carrier concentration. So P is representing the whole carrier concentration. First, let us derive it for the whole concentration. ఆ తర్వాత దాని ద్వారానే we will get the electron carrier concentration too. If we want, we can derive with this also, but for let us do it for the holes. Okay, so P represents the holes యొక్క carrier concentration. Students, before entering into the topic, I'm making this very clear that this is a very crisp in a topic. So I want your whole attention throughout the video. It's a very nice topic. It just says it's something very beautiful. It is saying that there is a variation with respect to time and distance. ఈ రెండిట్లు మారడం ద్వారా మన క్యారియర్ కాన్సన్ట్రేషన్ కూడా మారుతుంది. ఎలా మారుతుంది అని తెలుసుకోవడం కూడా ఇట్స్ అ కైండ్ ఆఫ్ డిటెక్టివ్ పిక్చర్. సో డూ కాన్సన్ట్రేట్. సో ఇది మారడం దాన్ని మనం ఈ పర్టికులర్ క్యూబ్లోని ఎలా మారుతుంది అనేది వీఆర్ జస్ట్ గివింగ్ అ క్వైట్ ఎక్స్ప్లెనేషన్. ఫర్ దిస్ వీ హ్యావ్ టు కన్సిడర్ 3 situations. 3 situations. Before that, our small infinitesimal cube is connected with the external electric field which is supplying the current I, and this is the intake ఇస్తున్న ఎలక్ట్రిక్ ఫీల్డ్, అండ్ ద వన్ విచ్ ఇస్ కమింగ్ అవుట్ సైడ్ ఇస్ I ప్లస్ DI. వై? ఎందుకు ఇస్తున్న దానికన్నా ఎక్కువ వస్తుంది? బికాస్ దిస్ సెమీ కండక్టర్ ఇస్ కంటైనింగ్ ది హోల్స్ యాజ్ వెల్ యాజ్ ది ఎలక్ట్రాన్స్. therefore ఇచ్చే కరెంట్ ద్వారా there will be a generation process through which the current will be either generated or it will be recombined. Din dwara there will be a change in the current which will be an additional current which comes outside the semiconductor. So I plus DI. So we are considering 3 situations. Okati, carrier concentration increase అయ్యే situation ఎప్పుడు? Carrier concentration increase అయ్యే situation ఎప్పుడు? When will the carrier concentration increase? When it is undergoing the generation process. Yes or no? It means the single electron is been splitting up into electron as well as the hole. సో ఇక్కడ 1 place లోని 2 జనరేట్ అవుతున్నాయి. ఇలాంటి ప్లేస్ లో క్యారియర్ కాన్సన్ట్రేషన్ అనేది ఇంక్రీజ్ అయిందా లేదా? Therefore the increase in the charge due to generation is my first case. Second situation is, as well as we have seen that in generation there is an increase. Mari recombination lo decrease ayinda leda? Charge yokka already present in the charge carriers decrease ayyaya leda? Therefore there is a decrease in the charge due to the recombination of holes as well as electrons. Holes and electrons. So the third situation, ఇంకేమైనా జరిగిందా ikkada? I am giving a supply of the electric field towards the semiconductor, So there is an extra electric field which is coming in terms of I plus DI. దీని ద్వారా ఏం జరుగుతుంది? There is a decrease in the charge due to the flow of, I think I need something. Due to the flow of current, or due to the change in the current, which is from I to I plus di. సో ఈ త్రీ సిచ్యువేషన్స్ అనే మనం కన్సిడర్ చేస్తున్నాం. ఈ త్రీ సిచ్యువేషన్స్ని కన్సిడర్ చేసేటప్పుడు ఐఎమ్ టాకింగ్ అబౌట్ ది ఫస్ట్ సిచ్యువేషన్, విచ్ ఈస్ ఇంక్రీజ్ ఇన్ ది చార్జ్ డ్యూ టు ది generation. We are talking about the first situation is this, and as well as the second situation is this, and as well as the third situation is this. Let tau p pd mean lifetime. As I told you, what is mean lifetime? అందుకే ముందుగానే చెప్పేశాను. టాపిక్ స్టార్ట్ చేయడానికి ముందే ఐ రివైజ్డ్ ద త్రీ థింగ్స్, విచ్ ఇస్ జనరేషన్, రికాంబినేషన్ అండ్ ది మీన్ లైఫ్ టైం. మీన్ లైఫ్ టైం అంటే ఏం చెప్పాను? The average time required for a charge from the point of the generation to reach to its recombination level, the time period is called as mean life time, which is represented with tau p. Then mean lifetime p అని ఎందుకు చెప్పాను ఇక్కడ? ఎందుకంటే we are considering here only whole carrier concentration, కాబట్టి the mean lifetime of wholes. Now then p అంటే ఏంటి? carrier whole concentration by tau p is nothing but the number of holes that is lost due to the recombination. రీకాంబినేషన్ అవడం వల్ల హోల్స్ అనేవి పోతాయా లేదా? సో ఈ మీన్ లైఫ్ టైం, సో the carrier concentration of the holes with respect to the time, with respect to the mean lifetime, when it is per mean lifetime, then this expression gives us that what these are nothing but the number of holes which were lost due to the recombination. So p by tau p is nothing but the number of holes that is lost due to the recombination. So now same page let us proceed. It's a very lengthy question, yet very crispy question. Chala everything is related to one on one. Lengthy ayinappatiki it is very easy. Okay, so now this we are considering one of this situation. ఇప్పుడు p by tau p is nothing but the number of holes that is lost due to the recombination. Now let us consider this decrease in the charge due to the recombination of holes and electrons. ఈ కేస్ ద్వారా వచ్చే ఈక్వేషన్ ఏంటో మనం ఇప్పుడు తెలుసుకుందాం. సో p by tau p number of holes lost due to recombination అయితే ఈ నెంబర్ ఆఫ్ హోల్స్ లాస్ట్ పర్ దిస్ వాల్యూమ్ ఎంత? ఈ వాల్యూమ్లో ఎన్ని హోల్స్ పోయాయి రీకాంబినేషన్ వల్ల అనేది we are going to see. So the decrease in charge in the volume due to the recombination is in T. ఎంత? ఈ p by tau p into మనం తీసుకున్న వాల్యూమ్ ఎంత అని చెప్పానమ్మా. సో దిస్ ఇస్ dx and this is a covering an area A. So this is A dx. ఇంటూ ఏం చేయాలి, ద యాక్చువల్ ఛార్జ్ ఆఫ్ ది ఎవ్రీ హోల్ యొక్క ఛార్జ్ ఇంటూ ది వాల్యూమ్ ఇంటూ ది నెంబర్ ఆఫ్ హోల్స్ ఆర్ లాస్ట్ because of the recombination will give us the decrease in the charge in the volume due to the recombination. First case అయిందా లేదా? Now let us consider the second case. Let G అనేది, let us consider G is the thermal rate of generation of whole electron pair యొక్క generation per unit volume. G అనేది, this is nothing but the thermal rate of generation ki telugu word endukle. So G is nothing but the thermal rate of generation of whole electron pair per unit volume. ఒక యూనిట్ వాల్యూమ్ లోని హోల్ ఎలక్ట్రాన్ పేర్ జనరేట్ అవ్వడానికి కావలసిన what do we say, the rate of generation of electron pairs is represented with G. Okay, ఆ G అనేది పర్ యూనిట్ వాల్యూమ్ తీసుకున్నాం. మరి ఇప్పుడు మనం తీసుకున్న వాల్యూమ్ కి కావాలంటే వాట్ ఈస్ నథింగ్, ఇట్ షుడ్ బి అగైన్ మల్టిప్లైడ్ విత్ ది వాల్యూమ్ యాజ్ వెల్ యాజ్ విత్ ది చార్జ్. సేమ్ రిపీటింగ్, G into ADX volume into charge of the whole Q. So it is nothing but Q into ADX into G. Second case వచ్చేసిందా? Now third case ఏంటి? It is nothing but the decrease in charge. It is nothing but the decrease in charge due to the current flow is DI. అవునా కదా? Decrease in charge is because of the current flow, the external ఏదైతే ఎక్స్ట్రాగా వచ్చిందో దీని ద్వారా ఎంతైతే చార్జ్ డిక్రీజ్ అయిందో దాన్ని we say that the decrease in charge due to the current flow is DI. సో ఇది కాకుండా we got the ఈ త్రీ సిచ్యువేషన్స్ యొక్క ఈక్వేషన్స్ మనకు వచ్చాయి. Now we are going to see the main, these are nothing but the RHS which we have. మరి LHS కూడా కావాలి కదా, we need the LHS too. LHS is nothing but we are going to see the due to all the three cases what is the whole concentration change within the volume. దీన్ని కనిపెట్టడం కోసమే కదా మనం ఈ త్రీ కేసెస్ తీసుకున్నాం. ఈ త్రీ కేసెస్ ద్వారా ఏ చేంజెస్ అనేవి జరిగాయి, రెండిటి ద్వారా డిక్రీజ్ అనేది జరిగింది, ద అదర్ వన్ ద్వారా దర్ ఇస్ అన్ ఇంక్రీజ్. ఎస్ ఆర్ నో? సో ఇదే కదా మన LHS అవుతుంది. సో దిస్ LHS విల్ బి గివెన్ బై మన వాల్యూమ్ ఏంటి, ADX. వాట్ ఈస్ ద చార్జ్ విచ్ వీ హ్యావ్, Q into rate of change of whole concentration with respect to time, which is given by dP by dt. Agree with me? Rate of change of whole concentration with respect to time is nothing but dP by dt. So LHS వచ్చేసింది, RHS వచ్చింది. Shall we recombine everything? So I am representing this with respect to, with the help of a small equation by Q into ADX into dP by dt is equal to increase దేని వల్ల జరిగింది, Q into ADX into G. There is a decrease in charge, therefore it will be minus. So P in by tau P into, I would have written Q, Q into ADX. Mali, there is a decrease in the flow because of minus DI. Let this be our first equation. So why is it minus అని అర్థమైంది కదమ్మా. I am taking very long time to understand, to make you understand each and every equation. Okay, so మైనస్లు అనేవి పెట్టడానికి గల రీజన్ ఏంటి? బికాస్ దెర్ ఇస్ అ డిక్రీజ్ ఇన్ ది చార్జ్. ఇది ఇంక్రీజ్ కి కారణం అయింది కాబట్టి I took this as positive sign. At the same time I took this negative signs because there is a decrease in the carrier concentration. So this will be our first equation. Okay, now let us consider an equilibrium state. Let us consider an equilibrium state. Equilibrium state ante entamma? Any idea? There is no change occurring in the system. There is no external field or ante nothing is affecting the system anedi we call it as an equilibrium state. So in this situation, equilibrium state ante enti dan artham? The external field which we are external field is not supplied. External feed not supplied అంటే I అనేది మనం సప్లై చేయట్లే. I అనేది లోపలికి వెళ్ళలేనప్పుడు అప్పుడు DI ఏమవుతుందమ్మా? జీరో కదా. DI will become 0. So now in equilibrium state, let us consider P is represented with P naught. P is represented with P naught. Okay, now ఇప్పుడు P is equal to P naught అయింది. So external గా మన field ఏ పని చేయట్లేదు. External గా we are not giving field. Then what will be the rate of flow of rate of change of whole concentration per unit time? Obviously external field ఇవ్వలేనప్పుడు this will also be equal to 0. Rate of change of whole concentration with respect to time because of not supplying the external field will be equal to 0. So what are the three consequences which we got? DI is equal to 0, P is equal to P naught, as well as dP by dt is equal to 0 under the consideration of equilibrium state. Equilibrium state consider chesam kabatti at that state we are getting three equations. Now can we put this in this equation? So ఒక్కసారి ఈ త్రీ కాన్సిక్వెన్సెస్ అనేవి ఈ ఈక్వేషన్ లో పెడితే ఏంటి? dP by dt is equal to 0 as well as di is equal to 0 as p is equal to p naught. అంతే, చేంజెస్ అనేవి ఏం జరిగాయి? పోనీ రాయనా, మళ్ళీ ఇంకోసారి రాస్తాను. q into a into dx dP by dt which is equal to q into a into dx g minus p by tau p q a dx minus di. ఇందులో ఏం పెట్టాం? di is equal to 0, p is equal to p naught as well as dP by dt is equal to 0. If you put this in this equation, what will it happen? q into a into dx into 0 is equal to q into a into dx into g minus p naught by tau p into q into a into dx minus 0. Then what will happen? A into q into dx p naught by tau p will be equal to q into a into dx into g. So a q dx cancel అయిపోతే ఏమొచ్చిందమ్మా? q is equal to p naught by tau p is what we got. Can we substitute the second equation in the first equation? Can we substitute this in the first equation? So substitute 2 substitute 2 in this first equation. Idega first equation. So now 2 in 1. What will happen to the equation? A into q into dx dP by dt is equal to a into q into dx p naught by tau p minus a into q into dx into p by tau p minus di. Let us consider this as our third equation. ఇక్కడ I is nothing but I is nothing but the total current due to the holes. if you people remember or not, I have told you the drift as well as the diffusion current. Drift as well as the diffusion current in a single class. It's a very beautiful class which we had. We have two wonderful equations which we got. Drift equation ochindi, diffusion equation ochindi. Ronditni we have combined to get a total current. Total RS manam we have calculated it. Once you can check for the reference in which we got whole concept. మనం we should consider only holes. అక్కడ మనం దేని కన్సిడర్ చేస్తాం? holes as well as the electrons. రెండింటిని మనం కంబైన్ చేసి ఒక ఈక్వేషన్ తీసుకొచ్చి in that equation we have given for the drift as well as in that equation, in the other equation which we have given is diffusion current. Diffusion current which we got for the electrons and the holes combined. So here we are calculating only for the holes. Therefore, if you people remember or not, just ఒకసారి రివైజ్ చేస్తే మీకు గుర్తొస్తుంది. Now the current I is due to the I diffusion due to holes plus I drift due to holes. So therefore I will be given as minus A into Q into dP into dP by dx plus A into P into mu P Q into E. అక్కడికి ఇక్కడికి పెద్ద డిఫరెన్స్ ఏ ఉండదు. ఇన్ ప్లేస్ ఆఫ్ ఈ అక్కడ మనం ఛార్జ్ ఈ అని తీసుకున్నాం, అక్కడ కూడా ఛార్జ్ ఈఏ, ఇక్కడ కూడా ఇన్ ప్లేస్ ఆఫ్ ఛార్జ్ వీఆర్ గివింగ్ క్యూ. సో నథింగ్ మోర్ విల్ బి అ డిఫరెన్స్. పీ ఈస్ నథింగ్ బట్ ది హోల్ కాన్సన్ట్రేషన్ అండ్ ఎవ్రీథింగ్ ఇస్ సేమ్. సో మనకి ఇక్కడ ఐ ఉంది, ఇక్కడ ఈక్వేషన్ లో వీ హ్యావ్ డిఐ. దేర్ ఫోర్ వీఆర్ జస్ట్ డిఫరెన్షియేటింగ్ దిస్ టర్మ్ విత్ రెస్పెక్ట్ టు differentiating the above equation. Let this be fourth equation antada. So differentiating this fourth equation with respect to dx cheste emoutundi, di by dx will be equal to minus a into q into dp d square p by dx square plus a into q into mu p into d by dx with respect to p into e. Okay, so ippudu kuda which we got is di by dx. What we want is di. Therefore we are just moving this dx towards this side. So di is nothing but minus a into dx into q into dp into d square p by dx square plus a into q into mu dx into dx into mu p into d by dx of p into e. This is our fifth equation. Now we are just substituting this fifth equation in substitute equation 5 in equation 4 in equation 3. Radama inkosari malli. Oh, if it is a classroom board it would be nice. So di is equal to manaki em ochindi minus a into dx into q into dp into d square p by dx square ochindi plus inke ochindamma manaki a into dx into q into mu p into d of p by dx is what we got as di. ఇప్పుడు దీన్ని మనం ఈక్వేషన్ 3 లో సబ్స్టిట్యూట్ చేయాలి. అంటే ఏంటి ఈక్వేషన్? a into q into dx into dp by dt is equal to minus a into q into dx into it's not visible. Minus a into q into dx into p by tau p plus aq into dx rho naught, p naught by tau p minus di place loni we are substituting this minus of minus a dx q dp into d square p by dx square plus a dx into q mu p into d of pe by dx. ఇవన్నిటిలో ఇఫ్ యూ సీ AQDX, 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 AQDX అన్నిటిలో ఇట్ ఇస్ కామన్. సో వీ కెన్ క్యాన్సిల్ ఇట్ అవుట్. వీ విల్ డూ ఇట్. రైట్, AQDX అనేది కామన్ తీస్తే dB by dt అనేది took it outside. Here it is represented with minus of AQDX కామన్ తీసాను, మైనస్ తీద్దాం, ప్లస్. సో మైనస్ P by tau P plus P naught by tau P minus of minus plus AQ dx అనేది బయటికి తీసేస్తే we are left with minus of minus plus dp into d square p by dx square minus of plus minus into adx ఇది బయటికి తీసేస్తే mu p into d of pe by dx is what we are left with. Cancel. So dp by dt is equal to p naught minus p. P naught minus p by tau p plus dp into d square p by dx square minus mu p into d of pe by dx. This is very clearly showing that the whole concentration is varying with respect to t as well as t and time, as well as it is varying with x, which is nothing but the distance. So the whole concentration is varying with respect to time as well as it is varying with respect to x. Now this can be represented in terms of dose, dou p by dou t, in the form of differential equation lo మనం ఇది మనం నోట్ చేయొచ్చు. In the form of differential equation. ఎందుకు we are using in place of d we are using dou p by dou t. Why? Because here the whole concentration is varying with respect to two terms. So we can write it as a differential equation in terms of dou. అందుకే మనం డీల్ ని మనం డోల్ కింద మారుస్తున్నాం. We are changing it in terms of the differential equation because it is varying with respect to two terms. First term is time as well as the second term is direction, distance. So ఈ రెండిటి ద్వారా మారుతుంది, వేరియేషన్స్ వస్తుంది కాబట్టి we are just converting into the differential equation, which is dou p by dou t is equal to p naught minus p by tau p plus dp into dou square p by dou x square minus mu p into dou of p by dou x. This is nothing but the continuity equation. This is nothing but the continuity equation. Continuity equation with respect to the whole carrier concentration. Similarly అని పెట్టేసి we will just note down at in terms of ఇది p అంటే ఏంటి, whole concentration, n అంటే ఏంటి, electron carrier concentration. So dou n by dou t is given by n naught minus n by tau n plus dp ని ఎలా మార్చొచ్చు, dn dou square p dou square n by dou x square minus mu p కాస్త mu n into dou by dou x with respect to n into e. This is the carrier concentration of in terms of electrons is carrier concentration in terms of holes. Variation with respect to time as well as the distance. This is nothing but the equation of continuity. It's a very beautiful answer. So I hope you all have got what I told you all. So quick revision idda. So 34 minutes. Okay, in 1 minute I'll give a quick revision. We are just taking the differential equation. We are talking about the equation of continuity. Equation of continuity is nothing but the differential equation, which is saying about the carrier concentration varies with respect to time as well as the distance. Let us consider a small semiconductor cube which has been passed with the current, external electric field and which is passing through it. It is giving an external extra electric field with which is represented with I plus di, and this volume of the cube is represented with a into dx, where dx is the length and area is the a. So volume is given by the a into dx. So P is nothing but the Hole's carrier concentration. I already told you about generation, recombination, and meanwhile mean lifetime. And you have known about increase in the charge due to the generation. See, the variations in the carrier concentration is because of the three cases. The first case is increase in the charge due to the generation, decrease in the charge due to the air combination, as well as the decrease in the charge due to the current flow, current change in the current flow, in the electric flow. Let tau p be the mean lifetime of the holes. Mean lifetime ante ento kuda already cheppanu and I won't repeat it. So P by tau p is nothing but the number of holes lost. The number of holes lost due to the recombination. Recombination avadam valla holes అనేవి డిసపియర్ అయిపోతాయి, బికాస్ ఎలక్ట్రాన్స్ వచ్చి దాని ప్లేస్లో సెటిల్ అయిపోతాయి కాబట్టి హోల్స్ అనేవి డిసపియర్ అయిపోతాయి. సో బికాస్ ఆఫ్ p by tau p is the number of the holes that is lost due to the recombination, as well as p by tau p అనేది యూనిట్ వాల్యూమ్ కి అయితే what will be for this volume which we have considered అని అంటే it is multiplied with the volume into the charge, adx into q into p by tau p is the decrease in the charge due to the recombination. Now increase in the charge due to the generation is nothing but is represented with g for unit volume. అదే మొత్తం మనం తీసుకున్న వాల్యూమ్ కి అయితే g into adx into q, which is represented with q into adx into g. So the decrease in the charge due to the current flow is di. Current ద్వారా కూడా మనకి there is a decrease in the charge. So ఈ three cases అనేవి will be our LHS. Then what will be our RHS? Now what will be our LHS? The question which is raising that what is the whole concentration change with respect to the volume అనేది the question which will be our LHS. So A into dx into q will be given by dp by dt. సో ఈ ఎల్హెచ్ఎస్ ఇస్ ఈక్వేటెడ్ విత్ ది ఆర్హెచ్ఎస్. ఆర్హెచ్ఎస్లో ఏమున్నాయి, డిక్రీజ్ అయిన 2 టర్మ్స్, ఇంక్రీజ్ అయిన 1 టర్మ్. ఆ మూడింటిని మనం ఈక్వేట్ చేసాం. ఈక్వేట్ చేసిన తర్వాత మనకి ఏం జరిగింది, ఇది ఒక ఈక్వేషన్ కింద కన్సిడర్ చేసి లెట్ us కన్సిడర్ అన్ ఈక్విలిబ్రియం స్టేట్ అని చెప్పుకుంటున్నాం. ఈక్విలిబ్రియం స్టేట్లో ఏం జరుగుతుంది, ఎక్స్టర్నల్ ఫీల్డ్ అనేది నాట్ సప్లైడ్. ఎక్స్టర్నల్ ఫీల్డ్ అనేది లేకపోతే డిఐ ఈజ్ ఈక్వల్ టు 0. అండ్ డిఐ ఈజ్ ఈక్వల్ టు 0 అయినప్పుడు లెట్ us కన్సిడర్ అన్ ఈక్విలిబ్రియం స్టేట్ పి ఈజ్ ఈక్వల్ టు పి నాట్. అండ్ obviously external field ఏ లేనప్పుడు what will be the rate of flow of change of whole carrier concentration? holes అనేవి జనరేట్ అవ్వవు కదా. సో dp by dt will be equal to 0. dp by dt will be equal to 0. ఈ 3 అనేవి we are substituting in this equation. మళ్ళీ ఇక్కడ రాశాను కాబట్టి ఆ ఈక్వేషన్ లో సబ్స్టిట్యూట్ చేసిన తర్వాత what we got g is equal to p naught by tau p. ఈ p naught by tau p ని ఈ g ప్లేస్ లో we are substituting. once after substituting we got an equation. let it be equal to 3. Let us consider I here is equal to the total current due to the whole of the holes. So the total current of the holes. So current of the holes అనేది ఎలా అవుతుంది, one it is because of the diffusion current and the other is because of the drift current. So diffusion current of the holes, drift current of the holes అనేవి మనం already ఒకసారి we have I have taught you in the classroom. So once if you refer the notes you'll get this. So I will be equal to this diffusion current of the holes into drift current of the holes. So differentiating the diffusion current, differentiating equation 4 with respect to x, we got this equation. We want di to substitute in this. Di is equal to dx into so and so equation. It is di lo substitute chesesanu. Once after substituting in di we got this equation. aq into dx అనేవి అన్నిటిలో కామన్ గా ఉన్నాయి. We got this equation. Once we got this equation, it is clearly showing that it is varying with respect to time as well as the distance. Since it is varying with the two variables, it will be converted into the differential equation in terms of dou and in terms of dose. ఇదంతా అయిపోయిన తర్వాత this is in terms of carrier concentration, in terms of carrier concentration of holes, carrier concentration of electrons. This is nothing but the equation of continuity. It's a very check to the very beautiful topic which is equation of continuity, which I couldn't deal with in the classroom. If it is in the classroom it will be more glorious. So hope you all have got very nice information in this video. It lasted for 39 minutes and 34 seconds I guess. So if you have any doubts you can ask me personally.